I would like to present to you Tipsy Homework, brought to you by River Horse. Some kind of beer that kind of gets you drunk. Well, first, let me just say, this is my first time in college for about 4, almost 5.5 years. Anyways, what I'm trying to say is, I don't know what the fuck I'm doing at all. So, I'm here tonight making flashcards because for the first time in almost 5 years, maybe more than 5 years, I'm not really sure, I actually have to use my brain. That's unfortunately what happens when you join the Navy. Your brain kind of dwindles away day after day. So, for my 3 main classes, actually 2 main classes and a 3rd class, which seems like it might be trying a little too hard. Anyways, I've made some flashcards and we're going to go over them tonight. First, I would like to go over biology. Oh, this is algebra. First, I would like to go over algebra. The bane of my existence, aka algebra, or math of any kind. Let's see what these have to say. Expressions. You know, I used to know expressions as, hey, excited, oh my gosh, how are you? Fuck you, I hate you, you're such a bitch. Angry, obviously. Things like that. But in math, these have a completely new meaning. So what is the meaning of expressions in math? I'll tell you. Apparently in math, you cannot solve expressions. Expressions are simply something as simple as x plus y, or x times y, or x over y. See? I know it's completely backwards because this is like a mirror image, so I'm sorry. But you cannot solve an expression. It is simply that, an expression. Next, we have an equation. Now, what is an equation? An equation includes an equal sign. So, an equation, for an example, would be x plus 1 is equal to 3, which would obviously make x 2. That, my friends, is an equation. We have sets. And you're asking, what are sets? Sets are a collection of objects whose elements are clearly determined. Whatever that means. So we have the roster method. The roster method lists the elements of the sets with commas in between and 3 dots indicating infinity. So that would be those crazy squiggly lines, 1, 2, 3, ... whoopsies, and then a squiggly thing. That is the roster method. Next, we have null sets. What is a null set? A null set is anything that has no elements. It's an empty set, and it's indicated by a 0 with a slash through it. Ta-da! Next, we have an intersection of sets. Intersection of sets is A, the little U thing upside down, B, and what it means is that whatever the numbers are common to both A and B. So, in order to figure this one out, I drew a little picture, and it's a circle of A, and it's a circle of B, and everything that intersects is in between the A and the B, hence the upside down U. I have no idea what to call this thing. It just looks like a U, and it's upside down, and it's not an N. Union of sets. Union is pretty much the opposite of the intersection. Union is everything included. So it actually looks like a U, but it's not a U. It just looks like a U. So pretty much in the circle, it includes everything from circle A and circle B. But when listed, it is listed in order. So instead of going 1, 5, 3, 9, whatever, it would go 1, 3, 5, 9, blah, 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 blah. All in order. Next, we have real numbers. Honestly, I'm not really sure why things are real numbers and fake numbers because numbers are numbers are numbers. I've never known a fake number before. But apparently, there are real numbers. So, for real numbers, we have rational numbers and irrational numbers. Rational numbers. Okay? So, sorry I have to look at these note cards. I'm still learning myself. Rational numbers are defined by a uppercase Q. That is how you express a rational number. Rational numbers are usually whole numbers identified by 1, 2, 3, etc. There are also integers and natural counting numbers. And we'll get to those in a second. Integers. Integers are our next. They're defined as an uppercase Z, even though uppercase Z's and lowercase z's look exactly the same except for their size. They're uppercase Z's, just in case you wanted to know. Okay, so integers can be anything from negative numbers to positive numbers, but they are whole numbers. So they could be -2, -1, -8, 1, 5, 7, whatever they are. They're whole numbers, but they are positive or negative. Now, for the natural counting numbers. Natural counting numbers are defined by an uppercase N, just in case you wanted to know. And an example of natural counting numbers would be numbers in a sequence. So it would have to go in order. So it would be 1, 2, 3, 4, skipping no numbers. That is a counting number, natural counting number. 1, 2, 3, 4, dot, 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 until the end. Irrational numbers. Sorry, irrational numbers. That's the Texan in me coming out. That's why I was putting stupid classes in English for the first God knows how long in my life. Imagine that, moving from Texas to Pennsylvania, there's a whole lot of difference in just the way you speak. Although I do say y'all still, and that tends to drive my dad pretty much insane. So I keep saying it, because I think it's hilarious. Okay, so for these irrational numbers, they're defined as Q exponent C, and that's a lowercase c. At least I think it is, because it looks like one. So, an example of an irrational number would be the square root of 2, which is, I really honestly don't know. I just know it's not a whole number. Same thing with the square root of 6. Pi. Pi is an irrational number because it's like 3.14 blah, 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 blah. And that's definitely an irrational number. Okay, now we've got this thing, and it's probably backwards to you guys, so I'm sorry about this. But this is the lesson sign, at least when I look at it. So lesson means the number that comes before the symbol is always less than the number that comes after it. So, for example, I have -4 is less than -1, which makes sense because -4 is smaller than -1. This is the greater than symbol. Pretty much the same thing in reverse. So, anything that comes before the symbol is greater than anything that comes after the symbol. So I have -1 is greater than -4, which is correct. Okay, now, here we have some expressions. Oh, how I love expressions. So, here's our absolute value. Absolute value is the distance of a number from 0. So, I have written out a number line right here. And I have 3 indicated on the number line. The distance from -3 to 0 and from +3 to 0 are both 3. So you would write that as the little lines that indicate a natural number, I guess, is -3 equals the absolute value of 3 is equal to 3. Ta-da! Okay. So, for the algebraic expressions, there are 5 different kinds of expressions. Those expressions include subtraction, division, and then the commutative property, associative property, and distributive property. See? Okay, hold on, I just messed up my cards. So, trying to reorganize them. Yikes. Okay. So, we're going to go over the subtraction property. Subtraction property pretty much states that whatever it is, a minus b is equal to a plus parentheses, negative b parentheses. So you have to change it around in a form in which your outcome would be the same regardless. Pretty simple. Although, unfortunately, this happens to be one of my biggest confusions. Negative numbers and I do not get along. It is the dumbest thing ever. Okay. Division properties. So if you have a divided by b, it's the same thing as saying a is times 1 over b. Yeah, that's the division property. Commutative property. It's pretty much a times b is equal to b times a, because no matter how you multiply something, it'll still come out to the same thing. Associative property. That's pretty much, that's kind of like foiling, you know? You take the first number in first, inner, outer, last. Well, if you FOIL A times B times C, it's the same thing as saying C times B times A. That is the associative property. Distributive property. This is a little different. It's kind of the same, but it's kind of different. So, with this one, you're going to multiply A times B times C, but B and C are added together. So when you redo it, you're going to say A times B plus A times C. Kind of simple. This is, in my mind, is how I FOIL things. It makes it easier for me to see it as this. So, that's what I do. And it usually works for me pretty well. The few times I've FOILed in the past couple years at least. Algebra for Dummies. Kind of works. Let's get on to exponents. These things piss me off. Especially the fucking negative ones. So, exponents. There are products, quotients, zeros, and negatives. There are 4 different types of exponents. Why? I have no idea. Although, for most of math, I have no idea why we do the things that we do. Because, to be honest with you, the most math I've ever used in my life is maybe multiplying or dividing something. Adding and subtracting, of course. But most advanced? Multiplying and dividing. Anyways, whatever. I didn't make it up. And I'm not the one running the school. Although I kind of wish I was. Okay. On to exponents. The product rule of exponents. Pretty much the product rule means that if you have 2 uncommon exponents and you're multiplying them, you add the exponents together. So if you have a to m times a to n, you add m and n together. And that is how you do the product rule. Now, we have the quotient rule. Quotient rule is pretty much when you're dividing two numbers with two different exponents. You would subtract the exponents from each other. So a to the m all over a to the n is equal times a m minus n. So you subtract those two. So if you had 2a to the second over a to the first, it would equal a to the second minus 1. A to the second, yeah. So that would be a to the first. That is how you do the quotient rule. Now, for zero exponents rule. For zero exponents rule, every exponent to the 0 is equal to 1. So no matter if you have 1,800,000 gazillion to the 0 exponent, the answer will always be 1. This is my favorite, by far. Now, last but not least, I hope you have enjoyed tonight, but we have one little card left, and this card happens to represent the negative exponent rule, which for some reason happens to confuse me the most out of any other rule, probably because it includes a bunch of fractions. And for some reason, fractions and I just don't get along. Well, anyways, for the negative exponent rule, if you have a to the negative n, the way you write it out is 1 over a to the positive n. That's all I know about it. Every time I try to do these problems, I fail at it. But in case you understand it, I am very glad for you. And I'm sure I will get it soon. But at this point, I'm still trying to figure everything out. I hope you liked Tipsy homework tonight. And I'll be back with more. Have a good night. And remember, River Horse, apparently it's called Cripple Horse. I have the Belgium style ale brewed with spices. It's pretty delicious. It's also 10% alcohol, which surprised the hell out of me because it doesn't even taste like it. Oh, and if you want to know, yes, I am of age. I am 22. So, I'm not breaking any laws here. I hope you had a great time trying to figure out your homework like I have. So, have a good night, and I'll see you next time.